Hello children, today we will be discussing about the first chapter of the 11th standard, that's sets. And this is a very important chapter because it has wide application in all the chapters. So let us start without wasting our time. Now what is a set? Set, by definition, it is like this. Set is a well-defined collection of distinct objects. So see, set is a word which is somewhat synonymous to the word called crowd, a collection or a group, but not every collection or a crowd can be called as a set. Now the definition, just see once again. Set is defined as well-defined collection. It should not be any collection, it should be well-defined collection. Now what do you mean by saying well-defined? When you say well-defined, it means that you must be able to say what all can be included in that collection. Which all elements or which all objects are there in the collection and which are not. Such a well-defined collection can be called as set. Okay, now what do you mean by saying that? Now suppose I take one example. See, teachers of my school. Isn't it well defined? My school, end school teachers. Oh, you can definitely say which all teachers or which all people come into that collection. And who are the teachers of your school, who are not the teachers. So this collection is well defined. So you can call this collection as a set. Am I right? Is it okay? Now, if I take another example, say vowels in English alphabet. In English alphabets. Now, what are the vowels in English alphabets? You know there are 5 vowels: A, E, I, O, U. So that's well-defined collection. So you can call this collection as a set. So vowels in English alphabet is a set. Say for example, I simply say a set of natural numbers. Natural numbers. Now what are natural numbers? You know numbers starting from 1 onwards, 1, 2, 3, 4, 5, 6, etc. So it's a well-defined collection. So you can call this well-defined collection as a set. So this is another example of what a set is. Now just see here. Let me take one example. Let us discuss whether this can be called as a collection, a well-defined collection or not. Suppose I just make a small change in this. I say good teachers of your school. Good teachers of, say, my school. Now when you say good teacher, a student named X will have a collection. A student named Y will have another collection. So this collection varies from student to student, which means that this collection is not well defined. So this cannot be called as a set. Though it is a collection, but it is not a set. Why is it not a set? Because it is not well defined. I hope the point is clear. So such types of examples, when you say another example, I take bright students of my class. So a teacher named X will list out a set of bright students. Another teacher of a different subject will list out another set of students who are bright for that teacher. So as individual vary, the number of students or the bright students will vary. So this is also not a well-defined collection. So you cannot call this as a set. So what is set? Again, coming to the definition, set is a well-defined collection of distinct objects. Now, let us now define what this means. Now, suppose I take one example. Suppose I say one example, say letters of the word mathematics. Letters of the word mathematics. So what are the letters of the word mathematics? See, it's a well-defined collection. When I say well-defined, means you know what are the letters that are there in mathematics. So it's a well-defined collection. Now, what are the letters of the word mathematics? You'll say like this: M is one letter, A is another letter, T is there, H is there, E is there, then C is there, S is there, I is also there. See, here M is coming 2 times. You don't need to say 2 times M. What are the letters of the word? These are the letters of the word that you see in this. So here what you have done is, you have not taken those letters twice or thrice which are being repeated here. One is enough. Once is enough. So you don't need to repeat letters which are repeating. You just say once. So distinct. All the elements are distinct. Now see, the definition becomes little more clear. What is a set? A set is a well-defined collection. We have defined that. And of what objects? Distinct objects. So all the objects must be different. So here all the letters are different. Is it clear? So this is the definition of what a set is. Now see here, let me just introduce a symbol which you are going to see in this topic, not only in this topic, throughout maths. Suppose I say a set named A. I'm just naming a set as A. Whatever be that set. And suppose an element X is there in A. X is an element of A. See, symbolically we write X, there is a symbol, this symbol, N. This symbol stands for belongs to. This is a very famous symbol which you will be seeing throughout the subject. So what is this meaning? It means X belongs to A. So if X is an element of A, you symbolically write X is belonging to A using this symbol. This symbol stands for belongs to. Suppose X is not in A. If you say X is not an element of A or not in A, it will be written as X. You'll write belongs to symbol and then cut it and then write A. It means X does not belong to A. Hope this is clear. So once again, just revisiting the definition. What is a set? Set means a well-defined collection of distinct objects. What do you mean by saying well-defined? You must be able to say which element belongs to the set and which does not belong to the set. What do you mean by saying distinct? You don't need to write a letter more than once in the set or in that collection. I hope the point is clear. Now listen here. Coming to the next point connected with the sets is, what are the different representations of sets? Now this is an important one. Representation of sets. Mainly, there are two representations. One is, we say, roster form. The second one is a set builder form. So there are two representations of a set. One, you can write the set in the roster form. Two, you can write the set in the set builder form. Let me take an example and I'll show you how to write that in the roster form, how to write it in the set builder form. Suppose I take a set A. A is equal to, I say the definition of A as even natural numbers. When I say even natural numbers, you know what are the even natural numbers? It's 2, 4, 6, 8, 10, 12, etc. And if you have to represent that in the roster form, this is how you do it. So let me take A equal to, you start with a curly bracket, write down the elements 2, 4, 6, 8, 10, separated by comma, and this goes on because there is no limit that has been stated here. So all types of natural numbers which are even will be there in it. So it's, you know that even natural numbers is infinite, so you just put some dot to say that this is infinite. This representation is called the roster representation. So in roster form, you list down the elements of the set, separated by comma, enclosed within curly brackets. And this representation is called what? Roster form. I hope this is clear, right? Suppose I say vowels. I say B is a set. B stands for vowels. Then you can say set B is equal to, you write down the elements of this. What are the vowels? You know, it is A, E, I, O, U. This representation is called the roster representation. So what is roster representation? You list down the elements of the set, separated by comma, enclose it within curly brackets. I hope this point is clear. Now, let me come to the next representation, that is the set builder form. What is set builder form? In this, what we do is, we just generalize it. we don't list down the elements. I'll just say this in the set builder form. See how you say A is equal to, you write like this. I'm going to represent even natural numbers in the set builder form. This is how you write. You say this set contains element x such that x is equal to 2n. 2n is a general format for even numbers. And let me say what n is. N belongs to capital N. You know capital N stands for natural numbers. This representation is called the set builder form. Now what is set builder form? You don't list the elements of the set, whereas you write the property of that set. So if you know the property, you can generate the elements of the set. That's all. Do you understand? Okay, say so for example, I take a case like this. A is equal to 1, 2, 3, 4. I'll just name this as say B. 1, 2, 3, 4, 5, 6, etc. You know these are natural numbers. The representation is the roster form. Let me represent this in the set builder form. So B is equal to x such that x is equal to, or x is an element of, you can say x is an element of n. What does n stand for? Natural numbers. So this becomes the roster representation of the set of natural numbers. I hope this is clear. So what is roster form? In the roster form, you don't list the elements of the set, whereas you list down or you write the characteristic property of the elements of the set. And this is very important when you come to your next levels of this topic. How to write in the roster form, or sorry, in the set builder form. Okay. Say for example, I take another case. Suppose I say a case like this. I am saying a set A is equal to set 1, 1 by 2, 1 by 3, 1 by 4, etc. This representation is the roster form. Let me write this in the set builder form. So this is equal to set builder form. You don't list the elements. You say the set contains element x. But what is x? X is equal to, I'll say 1 by n. They are reciprocals of natural numbers, isn't it? 1, 1 by 2, 1 by 3, 1 by 4, etc. What is n? N stands for natural number. See, completely explained in minimum terms, minimum words. And this representation is called the set builder form. Hope you understood what I said. So these are the two different representations of sets. One is the roster form and the set builder form. So you must know how to write a particular set in the roster form and also the set builder form, and vice versa. So if you're given a roster form, you can convert it to the set builder form and set builder to roster form. So hope the point is clear to you. Right? Okay. Now see here. Let me just introduce another important term from this. This is called a subset. Subset. What is a subset? Here, what you're going to do is you're trying to compare more than one sets. And what type of sets become subsets? Listen, if I take a set A and if I say set A is a subset of B, subset of another set, say B, see the symbolic representation for it will be A, and you write like this and then you write B. This C stands for contained in, or in other words, subset. What do you mean by saying like this? If you write like this, it means that A is a subset of B, or A is contained in B, right? Now, what do you mean by saying A is a subset of B? If all the elements of set A belong to set B, if all the elements of set A belong to set B, then you can say set A is contained in set B. Or in other words, set A is a subset of set B. And the symbolic representation for this is this. Suppose I am taking an example. I say a set A is equal to, I just write down, say, 3 elements 1, 2, 3. And B as, say, 1, 2, 3, 4. What you see now is all the elements of set A, 1, 2, 3, are there in set B, 1, 2, 3. So, which means set A is contained in set B, which means you can call A as a subset of B. And we write symbolically as A is a subset of B. See the difference between this representation and this representation. Here, in this case, I just said A is a subset of B. I did not say what A and B are. I did not say anything about the elements of set A and set B. So, which means you are not sure what type of elements are there in A and B. So, in some cases, the elements of A and elements of B will be the same and they are equal, which means they can become equal also. The two sets can become equal also. Then also you can say A is a subset of B. So, since you don't know whether it is properly contained or equal to, if you are not sure, then use this symbol. If you know that, see this example, A is contained in B and there are other elements in B which are not there in A. There you say A is properly contained in B and you write like this. This means A is a proper subset of B. Or you say B is a superset. You say A is a superset of A and it is written as B. You just reverse it and then write like this and will be read as B is a superset of A. Hope the point is clear. The difference between this subset and this symbol subset. Okay? Right. Now listen. See here. Let me just give you some more points connected with subset. So again we said if all the elements of set A are in B and if B contains at least one element more, then you can say A is a proper subset. Otherwise you'll say A is not a proper subset. Okay, suppose I take an example A is equal to set 1, 2, 3. Shall we write down the subsets of this? We'll write down the subsets of this. Now, to write down the subsets of this, you just keep in mind 3 points connected with the subset. Number 1. One is a null set is a subset of every set. What do you mean by saying a null set? A set with no elements is called a null set. Empty set or a void set. All are same. You can use the word void set. Void means null set. So what is a null set? A set with no elements. So a null set can be called as a subset of every set. So I can say one subset of this is null set. And how do you write a null set? See, this is one way of writing null set. You just write the curly brackets without writing any elements of it. So this is a subset of the set. 2. Every set is a subset of itself. I can say the elements of set A are in set A, which means A is a subset of A, which means now here I can say set 1, 2, 3 is a subset of set A because it is contained in this. This is the property. Every set is a subset of itself. Am I right? Now, what are the other subsets which you can list down? So, we have already listed down 2 subsets. What is it? One is the null set. Then set itself is a subset. Now, what are the other elements? See, I write like this, set 1. The elements of this set 1 is there in it. So, this set is a subset. Likewise, set 2 is a subset, set 3 is a subset, set 1 2 is a subset, set 1 3 is a subset, set 2 3 is a subset. So I have listed down all the elements, all the subsets of set A. So just count how many subsets are there. 1, 2, 3, 4, 5, 6, 7 and 8. A has 3 elements. A has 3 elements and we found that there are 8 subsets of this set. So now comes a third point which you have to know. If a set A has n elements, if there are n elements, then the number of subsets of A is the formula 2 raised to n. What does n stand for? The number of elements. Now see, set A is how many elements? 3 elements. So what will be the number of subsets of the set? Number of elements of set A. Number of elements of set A is 3. You write like this. Number of elements of set A is 3. So therefore what will be the number of subsets? So therefore number of subsets, formula says it is 2 raised to n or 2 raised to 3, which is 8. That's what we have seen here. So these are the 3 important points or properties connected with subset. Hope this point is clear to you. So what are the major points or properties connected with subset? A null set is a subset of every set. Every set is a subset of itself. And how many subsets can a set have? If a set A has n elements, number of subsets will be 2 raised to n. Clear? So the formula for this will be, the number of subsets for this will be 2 raised to 3, which is equal to 8. Now in these 8 subsets, there is one subset which is the set itself. And you should know that this is an improper subset. So suppose a question is asked, number of proper subsets. What will be the number of proper subsets? You'll say 2 raised to n minus 1. I hope this point is clear to you. So that's about subsets. I hope this point is clear. So just rewind whatever we have seen so far. What did we say so far? We said what a set is. What is a set? Set is a well-defined collection of distinct objects. What do you mean by saying well-defined? Well-defined means you must be able to say which all elements belong to the set and which do not belong to the set. Distinct objects means you don't need to repeat a letter more than once in the set. Now, that's about a set. Then, what are the different representations of sets? The different representations are mainly 2. Roster form and the set builder form. What is roster form? In the roster form, you list down the elements of the set, separated by comma, enclosed within curly brackets. So the curly bracket is being used in set representation. And what about set builder form? Here also you use curly bracket, but what is that you have to write inside the set builder form? In the set builder form, you don't list the elements, whereas you say the characteristic property of the elements of the set. Okay, so the 2 representations, roster form and the set builder form, and then we came to the next section called the subset. It's very important. Subset. What do you mean by saying subset? If A is a subset of B, what do you mean by saying that all the elements of set A will be contained in B? And this is the symbol of for is contained in or is a subset of. Then comes the important properties connected with the set. What are subset? What are the important properties connected? 3 important properties. A null set is a subset of every set. Every set is a subset of itself. If a set A has n elements, then the number of subsets will be 2 raised to n. Hope this much is clear to everyone, right? Okay, now let us pass on to some other points connected with this. Now children, let us try some questions from this. Just see this question. Consider the following sets. A is equal to set 1, 2, B equal to set 1, 4, 8, C is equal to set 1, 2, 4, 6 and 8. Insert the correct symbol. This is subset or not a subset between each of the following sets. Right? Insert the correct symbol in the space given below. Now, what is this? This is another symbol for null set. Either you can write like this or you can write like this. Both have the same meaning, null set. So, set, this is a set. So, phi is dash of B. We have studied a property, null set is a subset of every set. So, null set is a subset of B. Second, A and B. Try to connect A and B. A element 1, 2. B element 1, 4, 8. Now, you see that all the elements of set A are not in B. Set A has one element 2 which is not in B. So, you cannot call this as a subset. So, you see not a subset. What about A with the C? A has elements 1, 2. C has elements 1, 2. So, yes, A is a subset of C. So, it's a proper subset. What about B with C? B elements 1, 4, 8. C also has 1, 4, 8. So, yes, B is a subset of C. If all the elements of set A are in B, then A is a subset of B. So, we have now given the answers to this. I hope this is clear. Let us see the next case. Now, this is a question which will give you the difference between a subset and an element of a set. Let us say A is equal to set. Set contains elements A, B, set C, D, comma E. Once again, the elements of set A are A, B, set C, D, E. Remember, this is an element of the set A. Okay? Right. Now, let us see which of the following sets are false and why. It's given set CD is a subset of A. No, this is wrong. Why wrong? Because set C comma D is an element of A. So, this is false. We say this is false. We'll write false here. False. This is a false. Why? Because set C comma D is not a subset but an element of set A. What about here? See, this is fine. Set C comma D is an element. Yes, it is right. It's true. Or you write Y or I'll write true here. True. What about this one? See, set C comma D. Yes, an element in a set means it is now becoming a set and it is contained in this. In this set, you have an element which is there in set A. So, it is a subset. Yes, it is true. A is an element of A. Yes, A is an element of A. It is true. A is a subset of A. No, A is an element of A. Suppose you want to make it a subset, you should have a curly bracket for it. Now it becomes a set. And in this set, there is an element A which here. So you can say A is a subset. Otherwise, it is not. So it is not a subset. So here it is false. What about this? This is set A, B, E is a subset of A. Let us see A, B, E are there. Yes, A, B, E. 3 elements are there. Yes, so this is a set and the elements of this set belong to set A. So yes, it is a subset. What about the third case? Set A, B, E is an element of A. No, it is a subset. A, B, E, if it was just an element, then it should have been written in this manner. This is element. But when you have this in the curly brackets, it is not element, but it becomes a set. And now here, you see that all these elements are there in the set, which means it is a subset. So, this is false. What about this one? Set A, B, C. No, C is not an element. You should know that set CD is an element. There is no element C here. So, this is false. It is not a subset. And what about this one? Phi element of A. No, phi is actually a set. So, set means you can only connect with subset. The phi, we have already said, a null set is a subset of every set. So, it is not an element, but it is a subset. So, this is false. Hope this is clear. So, these two questions will give you a difference between a set and an element. a subset and an element. I hope the point is clear. Right.